Okay, sorry for the mix-up there. I just noticed I had a problem. So let's go through this. So we had the 2 points, and if we use the formula of first slope, the change of y over the change of x, here's the y values, 4 and 2. So we have 4 minus 2, change of y is 2. Here's the 2.5, 1.2. Subtract those, so we get 2 over 1.3. Calculate that out, and we get 1.54 meters per second. Now if we look at the stop, if you remember the last time we looked at this, it was for average speed, and we got a speed of, I think it was 0.75 meters per second. So we know it's supposed to be 0. But mathematically, I'm going to prove to you that it should definitely be 0. So there's the 2 points right there. Coordinates 3, 5 and 4, 5. The two y values, 5 and 5. 5 minus 5 is 0. 4 minus 3 is 1. Anything divided into 0 is going to be 0 meters per second. Okay, now here's where it gets a little more tricky. Only because it has to do with direction. We know that if you're moving away from the starting line, you get what's called a positive slope. In fact, if we went and looked back at the velocity, it's a positive number. Remember, any number, this number, that number, any number that you have without any other symbol in front of it is automatically a positive number. Here we're dealing with a slope of a line that is going in the opposite direction. Okay, this one's going up to the right, this one is going up to the left. Mathematically, we're going to get a different answer. So this was our run. Pick our 2 points. There's the coordinates. If you're not sure on which point to call y1 and y2 and x2 and x1, just go by the time. Which point came first? This point came first in time, so you have to pass the 5 seconds in order to get to the 5.5 seconds. So here's what this looks like. Here's a y, that's y2 minus y1, 4.25, oh sorry, y2, 2 minus 4.25. Notice you get a negative number. And you've got x2 minus x1. So 5.5 minus 5 gives you 0.5. Okay? The only reason that it's a little strange is that there's a negative number. This is a positive, this is a negative. Negative divided by a positive gives you a negative. So that is very significant because that negative number tells you something. It tells you it's going in the opposite direction. So if this line were flipped over so that it was actually going the opposite direction, and let's say it just continued up this way, same slope, it would say a positive 4.5. But because it's coming back opposite direction, it gets a negative relative to the other slopes. Okay, so that was an awful lot of work just to figure out the velocity, and granted we needed to do that, but why is it that we need to do that? Well, when you, as we already proved to you, you pick a point on a line, you're going to get a false reading because you're getting the average velocity. Everything that came before it influences whatever point, the speed at which the point is showing. By doing the slope, you eliminate every other point that is outside of those 2 points. Okay, so all other data, all stops, all other slow walks, all other anything else that came along. So it ignores everything except for what's between those 2 points. So it's almost like you just have one normal line like we started graphing at the beginning of the speed unit.